Hello everyone, welcome back to Maths Marathon classes. In this video, I'll be revising the trigonometric function chapter, all formula and concepts for various competitive exams. Okay, so we'll start from the definitions of radian measure, then discuss about trigonometric identities, standard angles, aligned angles, domain in range of trigonometric functions, graphs of trigonometric function, compound angle formula, addition and submultiple angle formula, double angle formula, triple angle formula, all those things, transformation formula, and the formulas which are exclusively required for JEE means, all those things. Okay, and also about trigonometric equations. We'll discuss all one by one in detail. Okay, so quick revision this will be for you. Starting from the radian measure. Radian is defined as the angle subtended at the center of the circle. Radian measure to start with. Radian measure is defined as the angle subtended at the center of a circle by an arc whose length is equal to the radius of the circle. So I'll just draw the rough sketch figure for you. This is a circle having center at O, and this angle we'll call it as 1 radian. Okay, angle AOB is said to be 1 radian if the arc length is equal to the radius of the circle. Angle subtended at the center is said to be 1 radian if the arc length AB is equal to the radius of the circle. Okay, if and only if AB, the arc length AB is equal to the radius of the circle. Okay, R is the radius of the circle. R is the radius of the circle. OA is same as OB, the radius of the circle. And if arc length is equal to the radius, then the angle subtended at the center is said to be 1 radian. Angle AOB is 1 radian if and only if arc length AB is equal to R. So I repeat once again, angle subtended at the center is said to be 1 radian if arc length is equal to the radius of the circle. So we have 1 radian, pi radians is equal to 180 degree. Some of the important relationship are right. Pi radians is equal to 180 degree. 1 radian is approximately equal to 57 degree, 16 minutes, 22 seconds. 1 degree is equal to 60 minutes. 1 degree is further divided into 60 parts. Each part is called as minutes, and 1 minute is equal to 60 seconds. And also I got the relationship between the radian measure and degree measure. Radian measure is equal to pi by 180 into degree measure. Okay, radian measure is equal to pi by 180 into degree measure. Rm stands for radian measure, dm stands for degree measure. And further I can write 1 radian is equal to 180 by pi degrees. 1 radian is equal to 180 by pi degree, and 1 degree is equal to pi by 180 radians. 1 degree is equal to pi by 180 radians. We write the symbol C here. C stands for the circular measure. Radian measure is also called as a circular measure. Hence the symbol C is used here. Okay. So all these things are a bit of information given to you connecting the degree measure and radian measure. Okay, and also we have the length of the arc is equal to r theta. Theta is a sectorial angle. Consider theta as a sectorial angle. This is the radius of the sector of a circle, okay, of radius r. L is the arc length. Then we have the relationship L is equal to r theta. Area of the sector is half r square theta, or you can write theta by 360 into pi r square also. Area of the sector is half r square theta, and perimeter of the sector is 2r plus r theta. Okay, area of the sector is half r square theta. R is the radius of the sector, L is the arc length, L is equal to r theta, and also we have the relationship. Perimeter of the sector is 2r plus r theta. Perimeter is sum of the sides, r plus L. So r plus r is 2r plus L is r theta. So 2r plus r theta we have. So this is r theta. Perimeter is r plus L. So r plus r is 2r plus L. So 2r plus r theta. Also we have the relationship between the radius, perimeter of the sector, and the sectorial angle. 2r square minus pr plus 2a equal to 0. Okay. If you substitute, 2a is going to be r square theta. Okay. 2r square. The pr is going to be 2r square plus r square theta. 2r square cancels. r square theta cancels. 2r square minus pr plus 2a equal to 0. It satisfies. If you want, you can substitute this. 2r into r. 2r square cancels. R theta into r square theta. 2a is also r square theta. These are the various relationship between the length of the arc, radius, arc length, area of the sector, perimeter of the sector, all those things. Okay, so this is about the radian measure we have, and also we got clock problems. If you want to find the angle between the minute hand and hour hand of a clock, it's given by theta is equal to mod of 30x minus 11y by 2. To find the angle between the minute hand and hour hand of a clock, this formula is useful, where x is in hours and y is in minutes. Okay, quite useful formula. X is in hours and y is in minutes. Mod of 30x minus 11y by 2. This is the formula useful to find the angle between the minute hand and hour hand of a clock. Suppose you get an answer more than 180 after doing this calculation. If you get the answer more than 180 degree, then you subtract that angle from 360 degree. 360 minus you do it, so that we get the internal angle. Okay, this is about the radian measure. Brief information is given to you, definition and the degree measure, radian measure, all those things. Okay. Next we have some of the important angles are expressed in terms of relationship between degrees and radian measure. 30 degrees pi by 6, 30 degrees pi by 6 radians, 45 degrees pi by 4, pi by 4, 60 degrees pi by 3, 75 degrees 5 pi by 12, 15 degrees pi by 12 of course, 15 degrees pi by 12, 90 degrees pi by 2, 360 degrees 2 pi radians, 360 degrees 2 pi radians. Suppose you want to find 150 degree, it is 5 pi by 6, 150 degrees 5 pi by 6. If you want, you can write is equal to everywhere. 30 degrees pi by 6, 45 degrees, 60 degrees, 75 degree, 90 degree, 360 degree, and 120 degrees 2 pi by 3. I am writing the relationship between the degree measure and radian measure, which are some of the important ones. 135 degrees 3 pi by 4, and 210 degrees 7 pi by 6. Okay, all these things is better to remember. 225 degrees 5 pi by 4, 240 degrees 4 pi by 3, 300 degrees 5 pi by 3, because pi by 3 is 60 degree, correct? 315 degrees 7 pi by 4, 7 pi by 4, and 330 degrees 11 pi by 6. All these things is better to learn. Okay, so relationship between the degree measure and radian measure, some of the important angles I have written here. So next we got the trigonometric identities. Sin square theta plus cos square theta is equal to 1. We have trigonometric identities. It's also called as the Pythagorean identities. Square relationship in trigonometry also we call this the trigonometric identities we have. The first one is sin square theta plus cos square theta is equal to 1. Also we can rearrange this and write cos square theta is 1 minus sin square theta is 1 minus cos square theta. Second one we have 1 plus tan square theta is equal to secant square theta. 1 plus cot square theta is equal to cosecant square theta. All these things we have. And one of the most important relationship between the secant square theta and secant theta plus tan theta and secant theta minus tan theta also can be deduced here. So one could written as secant square minus tan square, which is in the form of a square minus b square. So secant square minus tan square is secant theta plus tan theta into secant theta minus tan theta equal to 1. So I can write the relationship between secant theta plus tan theta and secant theta minus tan theta. Note that secant theta plus tan theta and secant theta minus tan theta are reciprocals of each other. Secant theta plus tan theta is equal to 1 by secant theta minus tan theta. And even we can write it for cosec theta plus cot theta and cosec theta minus cot theta. Correct? So that is cosec theta plus cot theta is equal to 1 by cosec theta minus cot theta. Okay, these are our reciprocal relationship we call between these two, cosecant plus cot and cosecant minus cot. It follows from the fact that they are reciprocals because of cosecant square minus cot square is equal to 1. So remember, secant theta plus tan theta and secant theta minus tan theta are reciprocals of each other. Similarly, we have cosec theta plus cot theta and cosec theta minus cot theta reciprocals of each other. And also the fundamental definitions of trigonometry functions also I can write. Sin theta is equal to opposite side by hypotenuse, the basic definition of trigonometry functions, and also I'll write here. So the learning from the beginning, so them it's useful for them. This is the angle theta here. I'll consider this triangle as ABC. Okay, this is for this angle theta. This is the adjacent side. This is adjacent side, and this is the opposite side. And the longest side of the triangle is the hypotenuse, which is the side opposite to the 90 degree hypotenuse. Okay, this is adjacent side. Sin theta is equal to opposite side divided by hypotenuse. Sin theta is opposite side BC divided by AC. Cos theta is equal to adjacent side divided by hypotenuse AB divided by BC. Sin theta is opposite side by hypotenuse. I can write opposite side divided by hypotenuse. Cos theta is adjacent side divided by hypotenuse. AB is the adjacent side. And tan theta is opposite side divided by adjacent side. Tan theta is opposite side divided by adjacent side. That is BC divided by AB. Correct? Opposite side divided by adjacent side. Tan theta. And we got the reciprocal functions. Opposite side divided by adjacent side. Sin is opposite by hypotenuse, cos is adjacent side by hypotenuse, tan is opposite by adjacent. And we got the reciprocal functions. Reciprocal functions are given by cosec theta, which is 1 by sin theta. Reciprocal functions we have. Reciprocal functions are cosec theta is equal to 1 by sin theta. For sin theta not equal to 0, of course. And we have secant theta is equal to 1 by cos theta. Cot theta is 1 by tan theta. Cot theta is equal to 1 by tan theta. Also I can write tan theta as a sin theta by cos theta. Tan theta is equal to sin theta divided by cos theta. And cot theta is equal to cos theta divided by sin theta. Okay. All these things quite useful in working out the problems. We have some results here. Sin x plus cos x the whole square I can write. Some of the results I can write connected to sin square theta plus cos square theta is equal to 1. Results are there. Cos x plus sin x the whole square plus cos x minus sin x the whole square is going to be equal to 2. You can remember this, quite useful in working out the problems. Cos x plus sin x the whole square plus cos x minus sin x the whole square is equal to 2. A plus b whole square plus a minus b whole square. 2 times a square plus b square. And I'm using cos square x plus sin square x is equal to 1. Similar to that, we have a cos x plus b sin x the whole square. A cos x plus b sin x the whole square plus b cos x minus a sin x the whole square. B cos x minus a sin x the whole square is going to be equal to a square plus b square. B cos x minus a sin x the whole square. A sin x the whole square is equal to a square plus b square is equal to a square plus b square. And also I told that secant theta plus tan theta and secant theta minus tan theta are reciprocals of each other. So for that I have another result here. Result, if secant x plus tan x is equal to p, if secant x plus tan x is equal to p, then we can write secant x minus tan x is equal to 1 by p. Secant x minus tan x is going to be equal to 1 by p. If you add the two equations, I can get secant x equal to p plus 1 by p by 2. That is secant x is equal to p square plus 1 by 2p. Secant x is equal to p plus 1 by p divided by 2, which is p square plus 1 divided by 2p I can write. So if you subtract the two equations, I can get tan x is equal to p square minus 1 by 2p. In other words, if secant x plus tan x is equal to p, then I can tell the angle is x here. P square plus 1, p square minus 1 and 2p form the sides of a right angle triangle. Okay, this is p square minus 1, this is p square plus 1 and this is 2p. with p square plus 1 being the hypotenuse. Whenever secant x plus tan x is equal to p, I can tell the angle is x for that triangle. No, I can tell p square minus 1, 2p and p square plus 1 are the sides of a right angle triangle. Of course, the square of p square plus 1 will be equal to sum of the squares of these two. 2p the whole square plus p square minus 1 the whole square is going to be p square plus 1 the whole square. Okay, so similarly I can write even for cosec x plus cot x equal to p, then cosec x minus cot x equal to 1 by p. I can write the similar kind of relationship. Okay, so with this we can go on to the next one. We have the domain and range of the trigonometric functions. All right, we know there are 6 trigonometric functions. I can write the domain and range of the trigonometric functions. Functions, domain and range. Functions, domain and range. There are 6 trigonometric functions: sin x, cos x, tan x, cot x, secant x and cosecant x finally. So using these I can write the domain and range. Domain means all possible values of x for which the function is well defined. Domain of sin x is r. Domain of cos x is r. Domain of tan x is all real numbers except 2n plus 1 pi by 2. Correct? 2n plus 1 pi by 2. N belongs to z. All real numbers except 2n plus 1 pi by 2. Domain of cot x is all real numbers except n pi. N belongs to z. Domain of all real numbers. Domain of secant x is all real numbers except 2n plus 1 pi by 2. Except 2n plus 1 pi by 2. N belongs to z. And note that domain of tan x and secant x is same, because tan is sine by cos and sec is 1 by cos. Denominator is same, so domain is same. Domain of cot x and cosec x is same. All real numbers except n pi. Cot is cos by sine and cosec is 1 by sine. Denominators are same, so domain is same. All real numbers except n pi. N belongs to z. Range also we can write for all the trigonometric functions. Range of the trigonometric functions. Range of this is sin x is the closed interval minus 1 to plus 1. Range of cos x is closed interval minus 1 to plus 1. Range of tan x is all real numbers. Range of cot x is all real numbers. Range of secant x is all real numbers except the open interval minus 1 plus 1. Range of cosec x is all real numbers except the open interval minus 1 plus 1. So range of secant x and cosec x could also be written as x belongs to R all real numbers. Secant x, of course, secant x belongs to all real numbers except minus 1 to plus 1. This is same as all real numbers except the open interval minus 1 plus 1 is the same as secant x is greater than or equal to 1 or secant x is less than or equal to minus 1. Okay, in other words, secant x will belong to the interval minus infinity to minus 1 union 1 to infinity. Secant x, even the cosec x also. Sin x lies in the interval minus 1 to plus 1, as well as cos x also lies in the interval minus 1 plus 1, and maximum value of sin x is 1, minimum value of sin x is minus 1. Tan x and cot x do not have minimum and maximum values. It extends from minus infinity to plus infinity. All real numbers means extends from minus infinity to plus infinity, the open interval, minus infinity to plus infinity. Secant x belongs to this interval, open closed interval, minus infinity to minus 1 union closed open interval 1 to infinity. Maximum value of sin x is 1, maximum value of sin square x is 1, maximum value of sin cube x is also 1. Okay, I can do the table for that if you want. The maximum and minimum values of higher powers of sin and cos. So if you want to take the function like this, sin square x, I can write function maximum value and minimum value. Maximum value and minimum value. Sin x, maximum value is 1, minimum value is minus 1. Cos x, maximum value is 1, minimum value is minus 1. Sin square x, maximum value is 1, minimum value is 0. Even for cos square x, maximum value is 1, minimum value is 0. If you take sin cube x, maximum value is 1, minimum value is minus 1. If you take cos to the power 7x, maximum value is 1, minimum value is minus 1. sine to the power odd number is given or cos to the power odd number is given, then maximum value is 1, minimum value is minus 1. If sine to the power even number is given or cos to the power even number is given, then maximum value is 1, minimum value is 0. All these things you must know. Okay, quite useful in working out the problems. Next, I'll go to some of the important standard angles. I can write the table for standard angles. So, you know, the angles are 0. I'll write express in terms of radian, that is better. Okay, 0 degree. In terms of radians, I'll express the standard angle table for all the trigonometric functions: sine, cos, tan, cot, secant and cosecant. The standard angle table. Angles are expressed in terms of radian here. 0, pi by 6, pi by 4, pi by 3 and pi by 2. Sine 0 is 0, sine pi by 6 is half, sine pi by 4 is 1 by root 2, sine pi by 3 is root 3 by 2, sine pi by 2 is 1. Cos 0 is 1, cos pi by 6 is root 3 by 2, cos pi by 4 is 1 by root 2, cos pi by 3 is half, cos pi by 2 is 0. Tan 0 is 0, tan pi by 6 is 1 by root 3, tan pi by 4 is 1, tan pi by 3 is root 3, tan pi by 2 is not defined. Cot 0 is not defined, cot pi by 6 is root 3, cot pi by 4 is 1, cot pi by 3 is 1 by root 3, cot pi by 2 is 0. Secant 0 is 1, secant pi by 6 is 2 by root 3, secant pi by 4 is root 2, secant pi by 3 is 2 and secant pi by 2 is not defined. Cosec is reciprocal of sine, cosec 0 is not defined, cosec pi by 6 is 2, cosec pi by 4 is root 2, cosec pi by 3 is 2 by root 3, cosec pi by 2 is 1. In the first quadrant, you see that sine function is increasing. Increasing function means as the angle increases, even the value also increases. Sine is increasing function in the first quadrant, 0 to pi by 2. As angle increases, value also increases. Cos is a decreasing function in the first quadrant. Angle increases from 0 to pi by 2, but value decreases from 1 to 0. 1 by root 2 is 0.707 and root 3 by 2 is 0.866. So it is increasing function, sine function. 0, 0.5, 0.707, 0.8661. Whereas cos is a decreasing function. 1, 0.866, 0.707, 0.50. Tan is increasing function. Cot is a decreasing function. Secant function is increasing and cosec is decreasing. Okay, in the first quadrant. So nature of different functions also we can discuss in different quadrants. And also we got the quadrantal angle values. Sine of n pi is equal to 0. You must know this. Sine of n pi is equal to 0 for all n belongs to z. For all n belongs to z. Cos of n pi is equal to minus 1 to the power n. Cos of odd pi is minus 1. Cos of even pi is plus 1. For all n belongs to z. Tan of n pi is equal to 0. Tan of n pi is equal to 0. Tan of every multiple of pi is equal to 0. For all n belongs to z. Sine of 2n plus 1 pi by 2 is equal to minus 1 to the power n. Sine of 2n plus 1 pi by 2 is minus 1 to the power n. For all n belongs to z. Cos of 2n plus 1 pi by 2 is equal to 0. These are all quadrantal angle values I am writing, okay, for all n belongs to z. And tan of 2n plus 1 pi by 2 is not defined. 2n plus 1 represents odd number. 2n plus 1 pi by 2 means it is odd multiple of pi by 2. Tan pi by 2 is not defined. Tan 3 pi by 2 is not defined. Tan 5 pi by 2 is not defined. Correct, all these things, quadrantal angle values. Sine of every multiple of pi is 0. Cos of odd pi is minus 1. Cos of even pi is plus 1. Tan of n pi is equal to 0. Sine of 2n plus 1 pi by 2 is minus 1 to the power n. Sine pi by 2 is 1. Sine 3 pi by 2 is minus 1. Sine 5 pi by 2 is 1. Sine 7 pi by 2 is minus 1. Can be got using this equation. And cos of odd multiple pi by 2 is equal to 0. Tan of odd multiple of pi by 2 is not defined. And in the interval 0 to pi by 4, if we observe, sine is smaller than cos. At pi by 4, they become equal. Sine and cos becomes equal at pi by 4. Correct. So in the interval, as for all x belongs to 0 to pi by 4, I can write sine is smaller than cos. If we compare the values of sine and cos, sine x is less than cos x in the interval 0 to pi by 4. For all x belongs to pi by 4 to pi by 2, in this interval, sin is bigger than cos. Okay, so you must know this. Sin x is greater than cos x for all x belongs to pi by 4 to pi by 2. 0 to pi by 4, sin is smaller than cos, and pi by 4 to pi by 2, cos is smaller than sin, or sin is bigger than cos. That you can observe from these values. At pi by 4 they become equal. Nature of sin and cos in the first quadrant. At pi by 4 they become equal. In the interval 0 to pi by 4, cos is bigger, and in the interval pi by 4 to pi by 2, sin is bigger. Okay, all these things you must know. Move on to the next one. We have some of the important formulas I can write here connected to the domain in range. One of the important results I can write. You know that maximum value of sine function is 1. So based on that we have this result: sine theta 1 plus sine theta 2 plus sine theta 3 etc. sine theta n. Sine theta 1 plus sine theta 2 plus sine theta 3 etc. sine theta n is equal to n, where n is a natural number. Then all of these sine function values should be equal to 1, because the maximum value of sine function is 1. Sine theta 1 is equal to sine theta 2 is equal to sine theta 3 is equal to sine theta n. All should be equal to 1, so that sum becomes equal to n. Similarly, we have for cos function values: cos theta 1 plus cos theta 2 plus cos theta 3 etc. Cos theta n is equal to n, where n is a natural number. Okay, n is a natural number. In that case, sum of this is equal to n. That means each of this cos function value should be equal to 1. Cos theta 1 is equal to cos theta 2 is equal to cos theta 3 etc. cos theta n. All should be equal to 1. And we have two more important formulas here: sin power 4x plus cos power 4x. Sin power 4x plus cos power 4x is equal to 1 minus 2 sin square x cos square x, which can be proved using the result a plus b whole square equal to a square plus b square plus 2ab. You take a equal to sin square x and b equal to cos square x, you can prove this. Sin power 4x plus cos power 4x is 1 minus 2 sin square x cos square x. 1 minus 2 sin square x cos square x. 1 minus 2 sin square x cos square x. Same way we have one more result, that is another formula: sin power 6x plus cos power 6x is equal to 1 minus 3 sin square x cos square x. 1 minus 3 sin square x cos square x. This can be proved using a plus b whole cube formula: a cube plus b cube plus 3ab into a plus b. Take a equal to sin square x and b equal to cos square x. We can prove this. Okay. And also I can write this in terms of the double angle formula as 1 minus half sin square to x. 1 minus half sin square to x. This expression is quite useful to find the range of sin power 4 plus cos power 4. And also I can find the range of sin power 6 plus cos power 6 using this. 1 minus, this will be 3 by 4 into sin square to x. Using sin x into cos x as sin 2x by 2. 1 minus 3 by 4 into sin square to x, and can find the range of sin power 4 plus cos power 4 using this. If you want to find the maximum value of this, take minimum value of sin square, which is 0. So 1 minus 0 is 1. So range of sin power 4x plus cos power 4x I can write using this. Range of sin power 4x plus cos power 4x is the maximum value is 1, and if you want to find the minimum value of this, take the maximum value of sin square x. Maximum value of sin square function is 1. So 1 minus half is 1. 1 minus half is half. So range is half to 1. Range is half to 1. Same way I can find the range of sin power 6x plus cos power 6x. Sin power 6x plus cos power 6x, already wrote the formula as 1 minus 3 by 4 sin square to x. If you want to find maximum value of this, take the minimum value of sin square function. Minimum value of sin square function is 0. So 1 minus 3 by 4 into 0, that is 1. Minimum, if you take, you'll get the maximum value. And if you take maximum value of sin square as 1, I get 1 minus 3 by 4, which is 1 by 4. Correct? So range is 1 by 4 to 1 for this. Sin power 4 plus cos power 4, range is half to 1. Sin power 6 plus cos power 6, range is 1 by 4 to 1. So quite useful results. Okay, take as a standard formula. Next, we move on to allied angles. Allied angles. Angles of this type, 90 plus or minus theta. I express in terms of radians only, that is better. So pi by 2 plus or minus theta, pi plus or minus theta. Angles of these type, pi by 2 plus or minus theta, pi plus or minus theta, 3 pi by 2 plus or minus theta, 2 pi plus or minus theta. These are called allied angles. Angles of these type are called as allied angles. To find the allied angle values, we use the following results or following things to be noted first. Okay, the first quadrant, this is second quadrant, third quadrant and fourth quadrant. The following things you should know. In first quadrant, all trigonometry functions are positive. First quadrant, I'll write A, and second quadrant, I'll write S. This is second quadrant. This is third quadrant. I'll write A, S, T, C. Okay. In first quadrant, all trigonometry functions are positive. Second quadrant, sine and reciprocal are positive, remaining are negative. In third quadrant, tan and cot are positive, remaining are negative. In fourth quadrant, cos and the reciprocal of cos, sec are positive, remaining are negative. First quadrant means angle varies from 0 to 90. So it is pi by 2 minus theta and 360 plus theta will fall to the first quadrant. Second quadrant is more than 90, less than 180. So it is pi by 2 plus theta and pi minus theta, like this. Third quadrant is more than 180 and less than 270. This is 3 pi by 2 minus theta. Third quadrant, more than 180, less than 270. This is 3 pi by 2 minus theta. More than 270 and less than 360. That is fourth quadrant. First quadrant, angles of this type, pi by 2 minus theta and 2 pi plus theta, 0 to 90. After completing one cycle also it comes to first quadrant. Of course, theta is an acute angle here. Okay, pi by 2 plus theta, 90 plus theta, more than 90, less than 180. The second quadrant. Third quadrant is more than 180, less than 270. The fourth quadrant is more than 270 and less than 360. Whenever you get angles of this type, pi by 2 plus or minus theta, angles of this type, pi by 2 plus or minus theta and 3 pi by 2 plus or minus theta. For this we write the corresponding co-functions. Pair of co-functions you must know. Sine and cos are the pair of co-functions. Tan and cot are pair of co-functions. Sec and cosec are pair of co-functions. Sine, cos, tan, cot, sec, cosec. Sine, cos, tan, cot, sec, cosec, the pair of co-functions. And whenever you get angles of this type, pi plus or minus theta, 2 pi plus or minus theta, for this we can write the same function. Write the same function. Okay, for angles of 180 plus or minus theta and 360 plus or minus theta, write the same function. Okay, for 90 and 270, write the corresponding co-functions. I can write the list of this, and whenever also you must know which quadrant the angle lies. 0 to 90 is first quadrant, 90 to 180 is second quadrant, 180 to 270 is third quadrant, 270 to 360 is fourth quadrant. Suppose you want to find sine of pi by 2 minus theta. Pi by 2 minus theta means it is first quadrant. First quadrant, all trigonometry functions are positive. So I can write plus. Pi by 2 means co-function. Co-function of sine is cos. Cos of pi by 2 minus theta is going to be equal to sine theta. Pi by 2 minus theta is first quadrant. First quadrant, all trigonometry functions are positive. Pi by 2 means co-function. Co-function of cos is sine. Sine theta. Tan of pi by 2 minus theta. Pi by 2 minus theta is first quadrant. First quadrant, all trigonometry functions are positive. Pi by 2 means co-function. Co-function of tan is cot. Cot of pi by 2 minus theta. Pi by 2 minus theta is first quadrant. First quadrant, all trigonometry functions are positive. Pi by 2 means co-function. Co-function of cot is tan. Sec of pi by 2 minus theta is equal to plus cosec theta. First quadrant, all trigonometry functions are positive. Pi by 2 means co-function. Co-function of sec is cosec. Cosec of pi by 2 minus theta. Cosec of pi by 2 minus theta is going to be equal to plus secant theta. This is the first set. Next we have for angles pi by 2 plus theta, right? Sine of pi by 2 plus theta. Sine of pi by 2 plus theta. Pi by 2 plus theta, second quadrant. Second quadrant sine function is positive. Pi by 2 means co-function. Co-function of sine is cos. Cos of pi by 2 plus theta. Pi by 2 plus theta is second quadrant. Second quadrant cos is negative, so minus. Pi by 2 means co-function. Co-function of cos is sine theta. Tan of pi by 2 plus theta. Tan of pi by 2 plus theta is equal to pi by 2 means pi by 2 plus theta is second quadrant. Second quadrant tan is negative. Pi by 2 means co-function. Co-function of tan is cot minus cot theta. Cot of pi by 2 plus theta. Cot of pi by 2 plus theta is equal to minus tan theta. Second quadrant. Pi by 2 plus theta belongs to second quadrant. In the second quadrant, cot function is negative. Pi by 2 means co-function. Co-function of cot is tan. Sec of pi by 2 plus theta. Pi by 2 plus theta is second quadrant. Second quadrant secant is negative. Pi by 2 means co-function. Co-function of sec is cosec. Cosec of pi by 2 plus theta. Pi by 2 plus theta is second quadrant. Second quadrant cosec is positive. Pi by 2 means co-function. Co-function of cosec is sec. Next I'll write for the angle pi minus theta of all trigonometric functions. Sine of pi minus theta. Sine of pi minus theta is equal to sine theta. Because pi minus theta means second quadrant. Second quadrant sine function is positive plus and pi means 180. 180 means same function. Cos of pi minus theta. Pi minus theta is second quadrant. Second quadrant cos function is negative. Pi means 180 degree. 180 means same function minus cos theta. Tan of pi minus theta. Second quadrant. Pi minus theta is second quadrant. Second quadrant tan function is negative. Pi means pi radians 180 degree. 180 means same function minus tan theta. Same way cot of pi minus theta is equal to minus cot theta. Secant of pi minus theta. Secant of pi minus theta is equal to minus secant theta. And cosec of pi minus theta is equal to plus cosecant theta. Second quadrant sine and cosec are positive. Because of this we have. Next we go to the angle pi plus theta. Pi plus theta is 180 plus theta, which belongs to third quadrant. Third quadrant we know tan and cot are positive, right? So using that I can write. For angles of the type pi plus theta, I'll write sine of pi plus theta. Sine of pi plus theta. Pi plus theta is third quadrant. In the third quadrant, sine function is negative. Pi means write the same function. Minus sine theta. Cos of pi plus theta. Cos of pi plus theta. Pi plus theta is third quadrant. Third quadrant cos function negative. Pi means write the same function. Minus cos theta. Tan of pi plus theta. Tan of pi plus theta is equal to plus tan theta. Because pi plus theta is third quadrant. In the third quadrant, tan function is positive. Pi means 180. 180 means same function. Plus tan theta. Cot of pi plus theta. Cot of pi plus theta is equal to pi plus theta is third quadrant. Third quadrant cot function is positive. Pi means same function. Cot theta. Pi and 2 pi should write the same function. Sec of pi plus theta. Pi plus theta being a third quadrant angle. Third quadrant secant function is negative. Pi means write the same function. So minus secant theta. Secant, next to write cosec. Cosec of pi plus theta. Cosec of pi plus theta. Pi plus theta is third quadrant. Third quadrant cosec is negative. Correct? Pi means write the same function. So minus cosec theta. So pi plus theta is over. Next I'll go to 3 pi by 2 minus theta. Sine of 3 pi by 2 minus theta I'll write. Sine of 3 pi by 2 minus theta. 3 pi by 2 minus theta is third quadrant. Third quadrant sine function is negative. 3 pi by 2 means co-function. Co-function of sine is cos. Cos of 3 pi by 2 minus theta. Cos of 3 pi by 2 minus theta is equal to 3 pi by 2 minus theta is third quadrant. Third quadrant cos function is negative. Correct? Co-function. 3 pi by 2 means co-function. Co-function of cos is sine. Tan of 3 pi by 2 minus theta. 3 pi by 2 minus theta is third quadrant. Third quadrant tan function is positive. 3 pi by 2 means co-function. Co-function of tan is cot. Cot of 3 pi by 2 minus theta. Cot of 3 pi by 2 minus theta is equal to 3 pi by 2 minus theta is third quadrant. Third quadrant cot function is positive. 3 pi by 2 means cofunction. Cofunction of cot is tan. Secant of 3 pi by 2 minus theta. 3 pi by 2 minus theta is a third quadrant angle. Third quadrant secant function is negative. 3 pi by 2 is cofunction. Cofunction of sec is cosec. Cosec of 3 pi by 2 minus theta. 3 pi by 2 minus theta is third quadrant. Third quadrant cosec is negative. Cofunction of 3 pi by 2 is 3 pi by 2 is cofunction. Cofunction of cosec is sec. Next we'll write for angles 2 pi minus theta. 3 pi by 2 minus 3 pi by 2 plus theta is there. Next we'll write for 3 pi by 2 plus theta. Sine of 3 pi by 2 plus theta. 3 pi by 2 plus theta means 270 plus theta. 270 plus theta is fourth quadrant. Fourth quadrant sine function is negative. 3 pi by 2 is cofunction. Cofunction of sine is cos. Cos of 3 pi by 2 plus theta. Cos of 3 pi by 2 plus theta. Fourth quadrant. 3 pi by 2 plus theta is fourth quadrant. In the fourth quadrant, cos function is positive. 3 pi by 2 is cofunction. Cofunction of cos is sine. Cos of 3, tan of next. Tan of 3 pi by 2 plus theta. Tan of 3 pi by 2 plus theta. 3 pi by 2 means cofunction. Cofunction of tan is cot and it is fourth quadrant. Fourth quadrant tan is negative. So minus cot theta. Cot of 3 pi by 2 plus theta. 3 pi by 2 plus theta is fourth quadrant. Fourth quadrant cot function is negative. 3 pi by 2 means cofunction. Cofunction of cot is tan. Sec of 3 pi by 2 plus theta. 3 pi by 2 plus theta is fourth quadrant. Fourth quadrant secant function is positive. 3 pi by 2 means cofunction. Cofunction of sec is cosec. Cosec of 3 pi by 2 plus theta. Cosec of 3 pi by 2 plus theta is equal to 3 pi by 2 plus theta is fourth quadrant. Fourth quadrant cosec is negative. 3 pi by 2 means cofunction. Cofunction of cosec is sec. I wrote for 3 pi by 2 plus theta. Next I'll go for 2 pi minus theta, which is also a fourth quadrant angle. Next I'll write for 2 pi plus theta. Ask the question to your mind which quadrant the angle belongs to. Then fix the sign. Then write same function or co-function. For pi and 2 pi, write the same function. For pi by 2 and 3 pi by 2, write the corresponding co-function. Hope it's clear. Next I'll write for 2 pi minus theta. Sine of 2 pi minus theta. 2 pi minus theta is fourth quadrant. Theta is acute angle we assume, correct? So fourth quadrant sine function is negative. 2 pi means write the same function. Cos of 2 pi minus theta. Cos of 2 pi minus theta is equal to plus cos theta. 2 pi minus theta is fourth quadrant. Fourth quadrant cos function is positive. 2 pi means write the same function. Tan of 2 pi minus theta. Tan of 2 pi minus theta is equal to minus tan theta. 2 pi minus theta is fourth quadrant. Fourth quadrant tan function is negative. 2 pi means write the same function. Cot of 2 pi minus theta. Cot of 2 pi minus theta. 2 pi minus theta is fourth quadrant. Fourth quadrant cot function is negative. 2 pi means write the same function. Secant of 2 pi minus theta. Secant of 2 pi minus theta. 2 pi minus theta is fourth quadrant. Fourth quadrant secant is positive. 2 pi means write the same function. Secant theta. Cosec of 2 pi minus theta. 2 pi minus theta is fourth quadrant. In the fourth quadrant cosec is negative. 2 pi means write the same function. Minus cosec theta. Sine of 2 pi plus theta. 2 pi plus theta is in the first quadrant. After completing one cycle, it falls to first quadrant. Every trigonometric function is positive in the first quadrant. 2 pi means write the same function. Cos of 2 pi plus theta. 2 pi plus theta is first quadrant. First quadrant, all trigonometric functions are positive. 2 pi means write the same function. Tan of 2 pi plus theta. plus tan theta. Cot of 2 pi plus theta is equal to plus cot theta. First quadrant, every trigonometry function is positive. Secant of 2 pi plus theta is equal to secant theta plus secant theta. 2 pi plus theta is a first quadrant. First quadrant, every trigonometry function is positive. And 2 pi means you write the same function plus cosec theta. Next, we also, every trigonometry function is a periodic function, means value repeats at a regular interval. I can write the periodicity of all trigonometry functions, and also we can write multiples of 2 pi can be added or subtracted for every trigonometry function. Okay, I'll write the trigonometry function and the corresponding period, function and the period, okay, for each of this trigonometry function. Sin x, the period is 2 pi. Cos x is periodic function with period 2 pi. Tan x is periodic function with period pi. Cot x is periodic function with period pi. Secant x and cosec x, they are periodic function with period 2 pi. And multiples of 2 pi can be added or subtracted for every trigonometry function because the value repeats at a regular interval, correct? And also we can write sine of minus, trigonometry functions of negative angles. Sine of minus theta is minus sin theta. Cos of minus theta is equal to cos theta. Tan of minus theta is equal to minus tan theta. Cot of minus theta is equal to minus cot theta. Secant of minus theta is equal to secant theta. And cosec of minus theta is equal to minus cosec theta. The definition of the periodic function is f of x plus p is equal to f of x, where p is the smallest positive real number. Where p is the smallest positive real number. Definition of the periodic function. Smallest positive real number. Okay. And multiples of 2 pi can be, 2 pi means 360 degree. So multiples of 360 degree can be added or subtracted. 360 into 1, 360 into 2, these kind of angles can be added or subtracted. Value of trigonometry function does not change. 360 into 1, 360 into 2 is equal to 720 degree. 360 into 3 is equal to 1080 degree. 360 into 4, which is 1440 degree. These kind of angles can be added or it can be subtracted. The value of trigonometry function does not change. The value of trigonometry function does not change. Multiples of 360 degree can be added or it can be subtracted. The value of trigonometry function does not change. These angles can be memorized. 360, 720, 1080, 1440, 1800. If large negative angle is given, you add multiple of 360. If large positive angle is given, you subtract multiple of 360. Okay, so that you can simplify using these angles. Okay, move on to the next one. We have a result here actually. Sin theta plus sin 360 minus theta is equal to 0. The first one we have sin theta plus sin of 360 minus theta is going to be equal to 0. Sin of 360 minus theta is equal to 0. Cos theta plus cos of 180 minus theta is equal to 0. Okay. Cos theta plus cos of 180 minus theta is equal to 0. And we have similarly tan theta plus tan of 180 minus theta is equal to 0. And I can write some examples there for this. Sin 1 degree plus sin 2 degree plus sin 3 degree plus etc. It goes on till sin 359 degree. This sum is going to be equal to 0. Already this question is asked in the exam, in CET exam. Already this question is asked. Sin 1 degree plus sin 2 degree plus etc. Sine 359 degree is equal to 0. It follows from this sine theta plus sine 360 minus theta equal to 0. We got 359 terms here. I can make 179 pays actually, and one is unpaid. Sine 180 itself is 0. So sum is 0. Okay, using this result. And we have cos 1 degree plus cos 2 degree plus cos 3 degree till cos 179 degree. The sum becomes equal to 0. Because cos 90 itself is 0. So it follows cos theta plus cos 180 minus theta is equal to 0. More results we have. If a plus b is equal to 90 degree, of course a and b are acute angles we can take. If a plus b is equal to 90 degree, if sum of the two angles is equal to 90 degree, where 0 less than a comma b less than 90 degree. Okay, a and b acute angles. Then we have this sine square a plus sine square b is equal to 1. Sine square a plus sine square b is equal to 1. Cos square a plus cos square b is equal to 1. Cos square a plus cos square b is equal to 1. Also, if sum of the two angles is 90 degree, product of tan functions is 1. Tan a into tan b is equal to 1. And also we have cot a into cot b is equal to 1. Sum of the two angles is 90 degree. Sin square a plus sin square b is 1. Cos square a plus cos square b is 1. Tan a into tan b is 1. Cot a into cot b is equal to 1. Cot a into cot b is equal to 1. I can write some examples connected to this. Suppose I ask to find the value of sin square. Examples for this. Sin square 5 degree plus sin square 10 degree. Multiples of 5 are present. Angles are sin square 15 degree, etc. goes on till sin square 90 degree. Using this first result, I can write. Using this sin square a plus sin square b equal to, I can write this sin square 5 plus sin square 10 plus sin square 15, etc. sin square 90. Count how many terms are there? There are 18 terms because multiples of 5 I can see the angles 5, 18s and 90. So 18 terms are there. 18 by 2 is 9. So answer is 9 and a half. 9 and a half. Similarly, I can write for cos square 5 degree. Cos square 5 degree plus cos square 10 degree plus cos square 15 degree. Like this it goes on till cos square 90 degree. This sum is going to be equal to 8 and a half. 18 terms are there. 18 by 2 is 9. 9 minus half. 8 and a half is the answer. Some more examples I can write connected to this. Suppose I give sin square 3 degree plus sin square 6 degree, sin square 9 degree. Like this it goes on till sin square 90 degree. How many terms are there? You count. There are 30 terms because multiples of 3 you can see. 3 into 30 is 90. 30 terms are there. 30 by 2 is 15. 15 plus half. 15 and half is the answer. Similarly, I can write for cos square. Cos square 3 degree plus cos square 6 degree plus cos square 9 degree. Like this it goes on. Okay. Till cos square 90 degree. Okay. Multiples of 3 are found. 30 terms are there. For cos function, 30 terms are there. 30 by 2 is 15. 15 minus half is 14 and a half. Directly we can write. Okay. So I can write few more examples for these two also. I'll write 2 more examples for the first 2 results itself here. That is sin square 1 degree plus sin square 2 degree, sin square 3 degree. This technique is applicable if it covers 45 degree. 45 degrees should be present in these kind of problems. Then only I can apply that method of writing the answer directly. I'm using sin square a plus sin square b equal to 1 and also using sin 45 degrees 1 by root 2, sin 90 degrees 1. 90 terms are there. 90 by 2 is 45. So answer is 45 and a half. Cos square 1 degree plus cos square 2 degree plus cos square 3 degree, etc. Cos square 90 degree. Here 90 terms are there. 90 by 2 is 45. 45 minus half. 44 and a half. Next I am going to write tan 1 degree into tan 2 degree into tan 3 degree, etc. Tan 89 degree. Product of this is going to be equal to 1. Product of this is going to be equal to 1 because of the result tan A into tan B is 1 if A plus B is equal to 90 degree. Similarly, I can write tan 10 degree into tan 20 degree, tan 30 degree, etc. It goes on till tan 80 degree. This product is also equal to 1. Same I can write for cot function. Cot 1 degree, cot 2 degree, cot 3 degree, etc. Cot 89 degree is equal to 1. It follows because of a plus b is equal to 90 degree. Cot a into cot b is equal to 1. Similarly, I can write for cot 10 degree into cot 20 degree into cot 30 degree, etc. Continue till cot 80 degree. The product is going to be equal to 1. Next we have the results. Few more results we have. If cos x plus secant x is equal to 2, if cos x plus secant x is equal to 2, then each of them should be equal to 1. Cos x is equal to secant x is equal to 1. Of course, there are some exceptions. Whenever the secant x is well defined, then only we can apply this. If cos x plus secant x is equal to minus 2, then cos x and secant x both should be equal to minus 1. Because maximum value of cos function is 1, correct? And minimum value of cos function is minus 1. And reciprocal of 1 is 1. So that cos and sec are reciprocal. The reciprocal of 1 is 1. 1 plus 1, 2. Cos x minimum value is minus 1. Reciprocal of minus 1 is minus 1 only. Minus 1 plus minus 1 is minus 2. Same way it applies for sin and cosec. If sin x plus cosec x is equal to 2, then sin x is equal to 1, cosec x is equal to 1. Both should be equal to 1. Sin x is equal to cosec x is equal to 1. If sin x plus cosec x is equal to minus 2, then sin x and cosec x both should be equal to minus 1. Sin x is equal to cosec x is equal to minus 1. If tan x plus cot x is equal to 2, then tan x is equal to cot x is equal to 1. Tan x is equal to cot x is equal to 1. If tan x plus cot x is minus 2, then also we have tan x equal to cot x equal to minus 1. Please make a note of all these things. Next we'll go to the compound angle formulae. Compound angle formulae. Sin of a plus b is equal to sin a cos b plus cos a sin b. Sin of a plus b is equal to sin a into cos b plus cos a into sin b. Sin of a minus b is equal to sin of a minus b is equal to sin a into cos b minus cos a into sin b. Cos of a plus b is equal to cos of a plus b is equal to cos a cos b minus sin a sin b. Cos of a minus b is equal to cos a cos b plus sin a sin b. tan of a plus b is equal to tan a plus tan b divided by 1 minus tan a tan b. Tan a plus tan b divided by 1 minus tan a tan b. Tan of a minus b is equal to tan a minus tan b divided by 1 plus tan a tan b. Next we have tan of pi by 4 plus a. Tan of pi by 4 plus a is equal to 1 plus tan a divided by 1 minus tan a. Tan of pi by 4 minus a is equal to tan of pi by 4 minus a is equal to 1 minus tan a divided by 1 plus tan a. Cot of a plus b is equal to cot of a plus b is equal to cot a cot b minus 1 divided by cot b plus cot a. Cot a cot b minus 1 divided by cot b plus cot a. Cot of a minus b is equal to cot of a minus b is equal to cot a cot b plus 1 divided by cot b minus cot a. Cot a cot b plus 1 divided by cot b minus cot a. Sin of a plus b into sin of a minus b is equal to sin square a minus sin square b. Sin square a minus sin square b. Cos of a plus b into cos of a minus b is equal to cos of a plus b into cos of a minus b is equal to cos square a minus sin square b. Tan of a plus b into tan of a minus b is equal to tan of a plus b into tan of a minus b is equal to tan square a minus tan square b divided by 1 minus tan square a tan square b. Please make a note of this. The most important formula is this. Many students make a mistake and frequently ask questions based on this. Cos of a plus b into cos of a minus b is cos square a minus sin square b. Here you should know the values here. Some of the important values. Sin 15 degree or sin pi by 12 call. Sin pi by 12 is root 3 minus 1 divided by 2 root 2. Cos pi by 12 is equal to root 3 plus 1 divided by 2 root 2. Tan pi by 12 is equal to 2 minus root 3. Sin pi by 12 is same as cos 5 pi by 12. Cos 75 degree. Sin 5 pi by 12 is same as cos pi by 12. Cos 15 degree same as sin 75 degree. Tan 15 degree same as cot 75 degree. Cot of 5 pi by 12. And tan 75 degree is 2 plus root 3. This is same as cot pi by 12. Note that pi by 12 is 15 degree and 5 pi by 12 is 75 degree. Sine 15 degree same as cos 75 degree. Cos 15 degree same as sine 75 degree. Tan 15 degrees cot 75 degree. Tan 75 degrees cot 15 degree. And one result we have here connected to this. If a plus b is equal to 60 degree, if a plus b is equal to 60 degree, we take a and b acute angles, that is better always. Both a and b 0 less than a comma b less than 60 degree. In that case, we have tan a plus tan b plus tan a into root 3 into tan a tan b is equal to root 3. Tan a plus tan b plus root 3 into tan a into tan b is equal to root 3. If a plus b is 45 degree, if a plus b is 45 degree, better take the angles in this form. 0 less than a comma b less than 45 degree. Both a and b lie between 0 and 45 degree. Then we have tan a plus tan b plus tan a into tan b is equal to 1. Because tan 45 degree is 1. Tan a plus tan b plus tan a into tan b is equal to 1. If a plus b is equal to 240 degree, if a plus b is 240 degree, then also we have tan a plus tan b plus root 3 into tan a tan b is equal to root 3. Tan a plus tan b plus root 3 into tan a into tan b is equal to root 3. A comma b is not equal to 90 degree will take. And a and b lie between 0 and 240. A and b both lie between 0 and 240, not equal to 90 degree. Because tan 90 degree is not defined. And we have, if a plus b is equal to 225 degree, in that case tan a plus tan b plus tan a tan b is equal to 1. Tan a plus tan b plus tan a into tan b is equal to 1. A and b not equal to 90 degree. A and b lie between 0 and 225 degree. All these things, results connected to compound angle formula we have. Next we have the double angle formulae. Sin 2 theta is equal to 2 sin theta cos theta. Sin 2 theta is equal to 2 sin theta cos theta is equal to 2 tan theta by 1 plus tan square theta. Cos 2 theta is equal to cos square theta minus sin square theta is equal to 2 cos square theta minus 1 is equal to 1 minus 2 sin square theta is equal to 1 minus tan square theta divided by 1 plus tan square theta. Tan 2 theta is equal to 2 tan theta by 1 minus tan square theta. These are all double angle formulae. Next we have the triple angle formulae. Sin 3 theta is equal to 3 sin theta minus 4 sin cube theta. Sin 3 theta is equal to 3 sin theta minus 4 sin cube theta. Cos 3 theta is equal to 4 cos cube theta minus 3 cos theta. tan 3 theta is equal to 3 tan theta minus tan cube theta divided by 1 minus 3 tan square theta. The power reducing formula we have, the power reducing formula, sin square theta is equal to 1 minus cos 2 theta divided by 2. Cos square theta is equal to 1 plus cos 2 theta divided by 2. Next we got the half angle formulas. Also called as the submultiple angle formula, half angle formula. Sin theta is equal to 2 sin theta by 2 cos theta by 2. 2 sin theta by 2 cos theta by 2 is equal to 2 tan theta by 2 divided by 1 plus tan square theta by 2. Cos theta is equal to cos square theta by 2 minus sin square theta by 2. Cos square theta by 2 minus sin square theta by 2 is equal to 2 cos square theta by 2 minus 1 is equal to 1 minus 2 sin square theta by 2 is equal to 1 minus tan square theta by 2 divided by 1 plus tan square theta by 2. Tan theta is equal to 2 tan theta by 2 divided by 1 minus tan square theta by 2. Important formula we have, tan theta plus cot theta is equal to formula tan theta plus cot theta is equal to 2 times cosecant 2 theta. Cot theta minus tan theta is equal to 2 times cot 2 theta. Tan of pi by 4 plus theta plus tan of pi by 4 minus theta. Tan of pi by 4 plus theta plus tan of pi by 4 minus theta is equal to 2 times secant 2 theta. Also we have, if tan of a plus b and tan of a minus b is given, if tan of a plus b is equal to p, tan of a plus b is equal to p, and tan of a minus b is equal to q, then tan 2a is equal to, you can write tan 2a. Tan 2a is tan of a plus b plus a minus b, which is p plus q by 1 minus pq. Many times questions are asked based on this. Next we write some simplified forms using this. Sin theta is 2 sin theta by 2 cos theta by 2. Cos theta is cos square theta by 2 minus sin square theta by 2. It's very important. Also I can write 1 plus cos theta as 2 cos square theta by 2. One more I'll write here itself. 1 plus cos theta is equal to 2 cos square theta by 2. And 1 minus cos theta is equal to 2 sin square theta by 2. 1 plus cos theta is 2 cos square theta by 2. 1 minus cos theta is 2 sin square theta by 2. Some of the simplified forms are required here. Simplified forms. Quite useful. First one is here. Sin theta divided by 1 plus cos theta. Sin theta is 2 sin theta by 2 cos theta by 2. 1 plus cos theta is 2 cos square theta by 2. If we simplify this, we get tan theta by 2. Sin theta divided by 1 minus cos theta. Sin theta divided by 1 minus cos theta is equal to cot theta by 2. One plus cos theta divided by 1 minus cos theta. 1 plus cos theta is 2 cos square theta by 2. 1 minus cos theta is 2 sin square theta by 2. If you simplify this, we get cot square theta by 2. Cos theta divided by 1 minus sin theta. If we simplify this, we get tan of pi by 4 plus theta by 2. Tan of pi by 4 plus theta by 2. Cos theta divided by 1 plus sin theta. Cos theta we can write cos square theta by 2 minus sin square theta by 2. 1 we can write cos square theta by 2 plus sin square theta by 2. Sin theta is 2 sin theta by 2 cos theta by 2. If we simplify this, we get tan of pi by 4 minus theta by 2. Also we can write the simplified form of secant theta plus tan theta. Secant theta plus tan theta, you can write it as 1 by cos theta plus sin theta by cos theta, which is 1 plus sin theta divided by cos theta. 1 plus sin theta divided by cos theta, which is reciprocal of cos theta by 1 plus sin theta. Cos theta by 1 plus sin theta is tan of pi by 4 minus theta by 2. Reciprocal of tan of pi by 4 minus theta by 2 is cot of pi by 4 minus theta by 2. This is cot of pi by 4 minus theta by 2, which is same as tan of pi by 4 plus theta by 2. Tan of pi by 4 plus theta by 2, using tan of 90 minus theta equal to cot theta. Same way we can write secant theta minus tan theta. The simplified form will be tan of pi by 4 minus theta by 2. Tan of pi by 4 minus theta by 2. Next we have cosec theta plus cot theta. Cosec theta plus cot theta is going to be equal to cot theta by 2. And cosec theta minus cot theta is equal to tan theta by 2. Simplified forms. Please make a note. Some of the important values I'll write here. Sin 18 degree is equal to root 5 minus 1 by 4. Sin 18 degree is equal to root 5 minus 1 by 4. Same as cos 72 degree. Sin 36 degree is equal to square root of 10 minus 2 root 5 divided by 4. Sin 36 degree is same as cos 54 degree by using allied angles. Cos 36 degree is equal to root 5 plus 1 by 4. Cos 36 degree is same as sin 54 degree. Cos 18 degree I can write. Cos 18 degree is equal to cos 18 degree is equal to root 5 plus 1 by 4. Cos 18 degree is same as, cos 18 degree is root of 10 plus 2 root 5 by 4. Cos 18 degree is equal to root of 10 plus 2 root 5 divided by 4, which is same as sin 72 degree. And tan pi by 8 is 22.5 degree. Tan pi by 8 is root 2 minus 1, which is same as 1 by root 2 plus 1. Tan pi by 8 is same as cot 3 pi by 8. Cot 67.5 degree. Tan 3 pi by 8, which is tan 67.5 degree, which is root 2 plus 1, which is 1 by root 2 minus 1. which is equal to cot pi by 8. If you want, you can write the value of sin pi by 8 also. Sin pi by 8, sin 22.5 degrees, root of root 2 minus 1 divided by 2 root 2. And cos pi by 8 is root of root 2 plus 1 divided by 2 root 2. And also I can write the value of tan 7.5, which is tan pi by 24. Tan pi by 24 and cot pi by 24. We can write the values of this. Tan pi by 24 is root 3 minus root 2 into root 2 minus 1. This is root 3 plus root 2 into root 2 plus 1. Tan pi by 24 and cot pi by 24. Pi by 24 is 7.5 degree. Pi by 12 is 15 degree. Pi by 24 is 7.5 degree. Next we have the results. If A plus B is equal to 45 degree, if A plus B is equal to 45 degree, better take A and B both lying between 0 and 45. Then 1 plus tan A into 1 plus tan B is equal to 2. 1 plus tan A into 1 plus tan B is equal to 2. Second one we have cot A minus 1 into cot B minus 1 is equal to 2. Next we have the results. Sin A into sin 60 minus A into sin 60 plus A. Sin A into sin of 60 degree minus A into sin of 60 degree plus A is equal to 1 by 4 sin 3A. Cos A into cos 60 minus A into cos 60 plus A. Cos A into cos 60 minus A into cos of 60 plus A is equal to 1 by 4 cos 3A. All these things very much useful even in JEE exams. Even the previous year questions, if you refer, these results are used in many of the problems. Tan A into tan 60 minus A into tan 60 plus A is equal to tan 3A. Please make a note of this. Examples for the second, right? Sin 10 degree into sin 30 degree into sin 50 degree into sin 70 degree is equal to 1 by 16. Cos 10 degree into cos 30 degree into cos 50 degree into cos 70 degree is equal to 3 by 16. Tan 10 degree into tan 30 degree into tan 50 degree into tan 70 degree is equal to 1 by 3. Sin 20 degree into sin 40 degree into sin 60 degree into sin 80 degree is equal to 3 by 16. Cos 20 degree into cos 40 degree into cos 60 degree into cos 80 degree is equal to 1 by 16. Tan 20 degree into tan 40 degree into tan 60 degree into tan 80 degree is equal to 3. results we have one more. If a plus b plus c is equal to 180 degree, if a plus b plus c is equal to 180 degree, then tan a plus tan b plus tan c is equal to tan a into tan b into tan c. Tan a plus tan b plus tan c is equal to tan a into tan b into tan c. If a, b, c are the angles of the triangle, of course a, b, c are not equal to 90 degree, we can take. Then we have cot a cot b plus cot b cot c, cot a cot b plus cot b cot c plus cot c into cot a is equal to 1. Third one we have cot a by 2 plus cot b by 2 plus cot c by 2 is equal to cot a by 2, cot b by 2, cot c by 2. Fourth one we have tan a tan b, tan a by 2 tan b by 2 plus tan b by 2 into tan c by 2 plus tan c by 2 into tan a by 2 is equal to 1. Next results we have sin square x plus pi by 3 plus sin square x minus pi by 3 is equal to 3 by 2. Similar to that we have cos square x plus pi by 3, cos square x plus pi by 3 plus cos square x minus pi by 3 is equal to 3 by 2. Third one we have sin theta plus sin of theta plus 2 pi by 3 plus sin of theta plus 4 pi by 3 is equal to 0. Sin theta plus sin of theta plus 2 pi by 3 plus sin of theta plus 4 pi by 3 is equal to 0. One came through all these things. I am writing all the results, formulas along with concepts. Cos theta plus cos of theta plus 2 pi by 3 plus cos of theta plus 4 pi by 3 is equal to 0. All these results are used already even in the 2024 JEE Main exam. Once the question was asked based on this result. So don't neglect all these results. What I am writing is one question was framed based on this result. Please make a note of this. Next we have one of the most important formulas called as the product of cosine functions where the angles are in GP we call. Okay. The product of cosine function where the angles are in GP. Product of cosine functions where the angles are in GP. GP is the geometric progression. We have this formula cos theta into cos 2 theta into cos 2 square theta cos of 2 cube theta cos of 2 power n minus 1 theta is equal to sine of 2 power n theta divided by 2 power n sine theta. Product of cosine functions where angles are in GP. There are n cosine functions and theta is the smallest angle, that you must know. Cos theta, cos 2 theta, cos 2 square theta, cos 2 cube theta and so on. Cos of 2 power n minus 1 theta is equal to sine of 2 power n theta divided by 2 power n sine theta. And the angles are in GP with common ratio 2. See, angles are getting double. Theta, 2 theta, 4 theta, 8 theta, like that. Angles are getting double. That's why I call angles are in GP with common ratio 2. Next, more to the next one. Sum of the sine and cosine series where the angles are in AP. Sum of the sine or cosine series. Sum of the sine or cosine series where angles are in AP. Where angles are in arithmetic progression. Sum of the sine or cosine series where the angles are in AP. The first one we have for sine series, alright, sine alpha plus sine of alpha plus beta plus sine of alpha plus 2 beta etc. up to n terms. Sine of alpha plus 2 beta etc. to n terms is equal to sine of n beta by 2 divided by sine beta by 2 into sine of alpha plus n minus 1 beta by 2. Note that the angles are in AP here. Angles are in AP. The common difference beta. Sine alpha plus beta plus sine alpha plus 2 beta etc. up to n terms is given by sine n beta by 2 divided by sine beta by 2 into sine of alpha plus n minus 1 beta by 2. Next we have sum of the cosine series where the angles are in AP. Cos alpha plus beta plus cos alpha plus 2 beta etc. up to n terms etc. up to n terms is equal to sine n beta by 2 divided by sine beta by 2 sine n beta by 2 divided by sine beta by 2 into cos of alpha plus n minus 1 beta by 2. Two important formulas exclusively required for JEE main exam. This and the earlier one, the product of cosine series where the angles are in GP. Here sum of the sine or cosine series where the angles are in AP. More to the next one, the maximum and minimum values of a cos x plus b sin x. I'll write the result here. The maximum value of a cos x plus b sin x. The maximum value of a cos x plus b sin x. The maximum value of a cos x plus b sin x is root of a square plus b square. Or you can write a sin x plus b cos x also. You can interchange a and b. Even still the result is same. Maximum value is root of a square plus b square. And the minimum value is minus root of a square plus b square. The minimum value of a cos x plus b sin x. Minimum value of a cos x plus b sin x is minus root of a square plus b square. In fact, I can write a cos x plus b sin x lies between a cos x plus b sin x lies between minus root of a square plus b square and root of a square plus b square. If I ask the range of a cos x plus b sin x plus c, a cos x plus b sin x plus c, that lies between c minus root of a square plus b square, c minus root of a square plus b square, and c plus root of a square plus b square. Mod. So next one, a transformation formula we have. Transformation formula, converting the product to sum and sum to product, called as transformation formula. Transformation formula. Sin C plus sin D equal to, sin C plus sin D is equal to 2 sin C plus D by 2 cos C minus D by 2. 2 sin C plus D by 2 into cos C minus D by 2. S plus S, 2SC we call. 2 cos C minus D divided by 2. Sin C minus sin D. Sin C minus sin D is equal to 2 cos C plus D by 2 sin C minus D by 2. Third one we have C plus C, 2CC, cos C plus cos D is equal to 2 cos C plus D by 2 cos C minus D by 2. 2 cos C plus D by 2 into cos C minus D by 2. Cos C minus cos D is equal to minus 2 sin C plus D by 2 sin C minus D by 2. Minus 2 sin C plus D by 2 into sin C minus D by 2. This is converting the sum to product. You can write in short as S plus S is equal to 2SC. S plus S is equal to 2SC. S minus S is equal to 2CS. C plus C is equal to 2CC. C minus C is equal to minus 2SS. S plus S equal to 2SC. S minus S 2CS. C plus C 2CC. C minus C minus 2SS. C stands for cos, S stands for sin. First angle is always C, second angle is always D. On right hand side, the first angle is always C plus D by 2, second angle is C minus D by 2. S plus S 2SC. S minus S 2CS. C plus C 2CC. C minus C is minus 2SS. Next we got converting the product to sum. Sin A cos B. Sin A cos B is equal to half sin A plus B plus sin A minus B. Sin A cos B is equal to half sin A plus B plus sin A minus B. Half sin A plus B plus sin A minus B. Cos A sin B. Cos A sin B is equal to half sin A plus B minus sin A minus B. Half sin A plus B minus sin A minus B. It's called defactorization formula. Half sin A plus B minus sin A minus B. Third one we have cos A cos B. Cos A cos B is equal to half cos A plus B plus cos A minus B. Half cos A plus B plus cos A minus B. Sin A sin B. Sin A sin B is equal to minus half cos A plus B minus cos A minus B. Minus half cos A plus B minus cos A minus B. This is called as defactorization formula. Sin A cos B half sin A plus B plus sin A minus B. Cos A sin B equal to half sin A plus B minus sin A minus B. Cos A cos B equal to half cos A plus B plus cos A minus B. Sin A sin B equal to minus half cos A plus B minus cos A minus B. Defactorization formula. Please make a note of this. Next, we move on to the trigonometric equation, finding the principal solution and the general solutions of trigonometric equation. Finding the solution of a trigonometric equation, we have two things. One is the principal solution and the general solution. To find the principal solution, you must know the definition. The value of x which satisfies the given trigonometric equation such that 0 less than or equal to x less than 2 pi is called as principal solution. 0 less than or equal to x less than 2 pi satisfying the given trigonometric equation is called as the principal solution. And the solution which is expressed in terms of the integer n or n pi I can call. That's called as general solution, expressing in terms of integer n. Because trigonometric equation, if it has a solution, then it can have infinitely many solutions because of the periodicity. Expressing in terms of the integer n, we get the general solution. In terms of the integer n, we get the general solution. To find the principal solution, we make use of the following things. Note that sin x equal to sin alpha means either x equal to alpha or x is equal to pi minus alpha. Sin x equal to sin alpha implies either x is equal to alpha or x is equal to pi minus alpha. Okay, alpha being an acute angle. Okay, because it's useful to write the general solution. The value of x which lies between 0 and 2 pi, including 0 excluding 2 pi, is called as principal solution, which satisfies given trigonometric equation. So x equal to alpha or x equal to pi minus alpha, because sine function is positive in the first quadrant or in the second quadrant. Cos x equal to cos alpha implies cos is positive in the first quadrant and fourth quadrant. So according to that, I am writing x is equal to alpha or x is equal to 2 pi minus alpha. Alpha is first quadrant, 2 pi minus alpha is fourth quadrant. Tan x equal to tan alpha. Tan x equal to tan alpha means x is equal to alpha or x is equal to pi plus alpha. As you know, tan function is positive in the first quadrant and third quadrant. Sin x equal to minus sin alpha if it is given. Sin x is equal to minus sin alpha if it is in this form. Then x is equal to pi plus alpha. As you know, sine function is negative in the third and fourth quadrant. X equal to pi plus alpha or x equal to 2 pi minus alpha. These things are useful to write the principal solution, also helpful to write the general solution. Cos x equal to minus cos alpha. Cos x equal to minus cos alpha implies, we know cos function is negative in the second and third quadrant. Second quadrant is pi minus alpha. Third quadrant is pi plus alpha. Even though it's a deleted topic from the NCERT book, the trigonometric equation, it is included for JEE Main. Exclusively it's required because many times questions are asked based on this trigonometric equations. Tan x equal to minus tan alpha, then x is equal to, tan function is negative in the second and fourth quadrant. Second quadrant is pi minus alpha, fourth quadrant is 2 pi minus alpha. Please make a note of this. Next, we have to find a general solution of sin x equal to sin alpha. General solution of the trigonometric equations. General solutions of trigonometric equations. Sin x equal to 0 means x is equal to n pi. Sin x equal to 0 implies x is equal to n pi, n belongs to z. Cos x equal to 0 implies x is equal to 2n plus pi by 2. N belongs to z. Tan x equal to 0 implies x is equal to n pi. Tan x equal to 0 implies x is equal to n pi, n belongs to z. Also we have sin x equal to sin alpha. Sin x is equal to sin alpha implies x is equal to n pi plus minus 1 to the power n alpha. N belongs to Z. Cos x equal to cos alpha. Cos x is equal to cos alpha implies x is equal to 2n pi plus or minus alpha. Cos x equal to cos alpha implies x is equal to 2n pi plus or minus alpha. 2n pi plus or minus alpha. N belongs to Z. Tan x equal to tan alpha. Tan x equal to tan alpha implies x is equal to n pi plus alpha. N belongs to Z. Then all these things quite useful to work out the problems for JEE Main exclusively. Next we have the general solutions of this equation. Sin square x equal to sin square alpha. The general solution of sin square x is equal to sin square alpha. Cos square x equal to cos square alpha. Tan square x is equal to tan square alpha. All these three have the same solution. X is equal to n pi plus or minus alpha. N belongs to Z. And next we have the general solutions of the equations of the type a cos x plus b sin x equal to c. The general solution of a cos x plus b sin x is equal to c. If you want to find the general solution of this equation, what we do is to divide the entire equation by root of a square plus b square. Because maximum value of a cos x plus b sin x is root of a square plus b square. To find the general solution of this equation, to divide the entire equation by root of a square plus b square. A by root of a square plus b square into cos x plus b by root of a square plus b square into sin x is equal to c by root of a square plus b square. A by root of a square plus b square is cos alpha into cos x plus b by root of sin a square plus b square defined as sin alpha. If you take this as cos alpha, this will be sin alpha because a, b and root of a square plus b square form the sides of right angle triangle, correct? If you define cos alpha as a by root of a square plus b square, automatically the sin function will becomes b by root of a square plus b square because a, b and root of a square plus b square form the sides of the right angle triangle. This I'll define it as cos beta. This will be cos of x minus alpha. Cos of x minus alpha equal to cos beta. And the general solution of this is given by x minus alpha is equal to 2n pi plus or minus beta. Okay. From this I can write x is equal to 2n pi plus or minus beta plus alpha, where n belongs to Z. General solution of the equation of this type. Divide the entire equation by root of a square plus b square and get the answer. Move on to the next one. We have the properties of triangle here. Properties of triangle. To study about this, you must know that a triangle has 6 elements. Properties of triangle. It's also called as relation between the sides and angles of a triangle. A triangle has 6 elements. There are 6 elements for a triangle, namely 3 sides and 3 angles. The 3 sides are denoted by small letters A, B, C, small letters A, B, C, and 3 angles are denoted by capital letters A, B, C. You must know this. 3 sides and 3 angles of a triangle. In general, we have a triangle ABC like this. A triangle ABC is given to you. A triangle ABC. BC is represented by A, AC is represented by B, and AB is represented by C. This is a standard way of denoting a triangle. Triangle has 6 elements, 3 of them are sides denoted by small letters A, B, C, and the angles, 3 angles denoted by capital letters A, B, C. BC is represented by side A, AC is represented by side B and AB is represented by the side C. Small letters denote the sides, capital letters denote the angles. We got some of the important rules like sine rule, cosine rule, Napier's rule, projection rule. Okay, the first one, the sine rule we have. The sine rule says that in any triangle ABC we have the sine rule. In any triangle ABC. In any triangle ABC, we have A by sine A is equal to B by sine B is equal to C by sine C. A by sine A is equal to B by sine B is equal to C by sine C is equal to 2R, where R is the circumradius of the triangle, where capital R is the circumradius of the triangle. Capital R is the circumradius of the triangle. Also note that by using sine rule I can tell A is to B is to C. The sides of the triangle are proportional to sine of their opposite angles. Sides of the triangle are proportional to sine of their opposite angles. This is about the side. Next we have the cosine rule. The cosine rule. In any triangle ABC we have. In any triangle ABC means the triangle can be acute angle triangle or right angle triangle or obtuse angle triangle. In any triangle ABC we have A square is equal to B square plus C square minus 2BC cos A. Same way we can write for this. B square is equal to C square plus A square minus 2AC into cos B. Third one we have C square is equal to A square plus B square minus 2AB into cos C. Or if you take a triangle ABC, okay, ABC is a triangle, BC is represented by A, AC is represented by B, AB is represented by C. So you can write cos A is equal to, if you want to find cos A, cos of this angle A, take sum of the squares of the adjacent side, subtract the square of opposite side, B square plus C square, B square plus C square minus A square divided by 2BC. Cos B is equal to, cos of this angle is equal to, take sum of the squares of the adjacent side, subtract the square of the opposite side, A square plus C square minus B square. Cos B is equal to A square plus C square minus B square divided by 2AC. Similarly, I can write cos C is equal to cos of this angle C. For this angle C, the adjacent sides are A and B. So take the sum of the squares of the adjacent side, subtract the square of the opposite side. So that is numerator. Cos C is equal to A square plus B square minus C square divided by 2AB. This is the cosine rule. Please make a note. How to apply cosine rule in a triangle. Suppose you are referring to angle A, cos A is equal to the numerator. So take the sum of the squares of the adjacent side, subtract the square of opposite side, divided by 2 into product of the adjacent sides. That is how we write. Cos B is equal to, take sum of the squares of the adjacent side, subtract the square of opposite side, divided by 2 into product of the adjacent sides. Okay, this is how we write the cosine rule. Next we have the Napier's rule. The Napier's rule says in any triangle ABC, the Napier's rule. Napier's rule. In any triangle ABC, we have in any triangle ABC, tan of A minus B by 2 is equal to, tan of A minus B by 2 is equal to A minus B by A plus B into cot C by 2. A minus B by A plus B into cot C by 2. Second one, tan of B minus C by 2 is equal to, tan of B minus C by 2 is equal to B minus C divided by B plus C into cot A by 2. Tan of A minus C by 2 is equal to tan of A minus C divided by 2 is equal to A minus C divided by a plus c into cot b by 2. This is about Napier's rule. Next we have the projection rule. The projection rule. In any triangle ABC we have, in any triangle ABC, we have A is equal to B into cos C plus C into cos B. Second one I have B is equal to A into cos C plus C into cos A. Third one we have C is equal to A into cos B plus B into cos A. This is about the projection rule. Please make a note of this. Next, I have write some results here connected to this triangle trigonometry. If cos A by A in any triangle ABC, in a triangle ABC, alright. If cos A by A is equal to cos B by B is equal to cos C by C, then the triangle is equilateral. Triangle is equilateral in this case. If it satisfies A sin A is equal to B sin B, A sin A is equal to B sin B, then the triangle is isosceles. If it satisfies this condition, A cos A is equal to B cos B, A cos A is equal to B cos B, then the triangle is either isosceles or right angle. Also we have another set of result here. In triangle ABC we have, in triangle ABC, if sin A plus sin B plus sin C is equal to 3 root 3 by 2, sin A plus sin B plus sin C is equal to 3 root 3 by 2 implies triangle is equilateral. Triangle is equilateral. If cos A plus cos B plus cos C is equal to 3 by 2, then also we can tell the triangle is equilateral. Cos A plus cos B plus cos C equal to 3 by 2. Triangle is equilateral. Tan A plus tan B plus tan C is equal to 3 root 3. Tan A plus tan B plus tan C is equal to 3 root 3. Then also the triangle is equilateral. Next we have area of triangle. Area of triangle is given by. Area of triangle is given by the formulas. Delta denotes the area of the triangle. Delta is equal to half AB sin C. Half AB sin C is equal to half BC into sin A is also equal to half AC into sin B. Delta is also equal to R into S, where R is in radius, S is the semi-perimeter of the triangle, where R is the in radius. R is in radius and S is the semi-perimeter. S is given by A plus B plus C divided by 2. It's called as semi-perimeter. Delta is also given by the formula ABC by 4R, where capital R is the circumradius. Where capital R is the circumradius of the triangle. in radius of the triangle. Delta is also given by root of s into s minus a into s minus b into s minus c, where s is the semi-perimeter of the triangle, a plus b plus c by 2, semi-perimeter of the triangle, perimeter of the triangle divided by 2. It's called as Heron's formula. It's called as the Heron's formula. Also, we have the relationship between the in radius and circumradius is given by the formula small r is equal to 4r into sine a by 2 sine b by 2 sine c by 2. And in case of equilateral triangle, angle ABC all are equal to 60 degree. 60 by 2 is 30. Sine 30 cube I'll get. Sine 30 cube is half cube 1 by 8. For equilateral triangle I get r is equal to capital R by 2. For an equilateral triangle, we have small r is equal to capital R divided by 2. We have small r is equal to capital R divided by 2. Okay, this is about area of triangle. And we got also half angle formulas for sine, cos and tan here. Sine a by 2 is given by more formulas we have for sine a by 2, sine b by 2, sine c by 2. Sine a by 2 is given by root of s minus b into s minus c, s minus b into s minus c divided by bc. And sine b by 2 I can write. Sine b by 2 is equal to root of s minus a into s minus c divided by ac. Sine c by 2 is equal to root of s minus a into s minus b divided by ab. Similarly, we got cos a by 2 formula. Cos a by 2 is equal to root of s into s minus a divided by bc. Cos b by 2 is equal to root of s into s minus b divided by ac. Cos c by 2 is equal to root of s into s minus c divided by ab. If you want tan a by 2, you can do sin a by 2 by cos a by 2. Tan a by 2 is equal to root of s minus b into s minus c, s minus b by into s minus c divided by s into s minus a. Tan b by 2 is equal to root of s minus a into s minus c divided by s into s minus b. Similarly, I can write tan c by 2 formula. Tan c by 2 is equal to square root of s minus a into s minus b divided by s into s minus c. Half angle formulas. Next, I am going to draw the graphs of all the 6 trigonometric functions and study the nature in each quadrant. Graph of y is equal to sin x. Graph of y is equal to sin x. We'll mark the quadrantal angles here. 0, pi by 2, pi, 3 pi by 2, 2 pi. On the left side of original mark minus pi by 2, minus pi, minus 3 pi by 2, minus 2 pi. Maximum value of Sine function is 1, minimum is minus 1, correct? Sine 0, 0, sine pi by 2 is 1, sine pi is 0, sine 3 pi by 2 is minus 1, sine 2 pi is 1, sine of minus pi by 2 is minus 1, sine of minus pi is 0, sine of minus 3 pi by 2 is plus 1, sine of minus 2 pi is 0. Graph of y is equal to sine x. And in the first quadrant, it increases from 0 to 1. Second quadrant decreases from 1 to 0. Third quadrant decreases from 0 to minus 1. Fourth quadrant increases from minus 1 to 0. How is the nature of sine function? In the first quadrant, second quadrant, third quadrant, and fourth quadrant. I can write. In the first quadrant, sine function increases from 0 to 1. Increases, arrow mark up means increases. In the second quadrant, decreases from 1 to 0. Decreases from 1 to 0. In the third quadrant, decreases from 0 to minus 1. Decreases from 0 to minus 1. And in the fourth quadrant, increases from minus 1 to 0. Increases from minus 1 to 0. This is about graph of sine x. How it behaves? In the first quadrant increases from 0 to 1. Second quadrant decreases from 1 to 0. Third quadrant decreases from 0 to minus 1. Fourth quadrant increases from minus 1 to 0. Increasing, decreasing, decreasing, increasing. Next, we'll draw the graph of y is equal to cos x. Graph of y is equal to cos x. Graph of y is equal to cos x. Pi by 2, pi, 3 pi by 2, 2 pi. Here it is minus pi by 2, minus pi, minus 3 pi by 2 minus 2 pi. Maximum value of cos x is 1 and the minimum value of cos x is minus 1. Knowing the quadrantal angle values, I can draw the graph. Cos 0 is 1, cos pi by 2 is 0, cos pi is minus 1, cos 3 pi by 2 is 0, cos 2 pi is 1. Cos of minus pi by 2 is 0, cos of minus pi is minus 1, cos of minus 3 pi by 2 is 0, cos of minus 2 pi is 1. This is the graph of y equal to cos x. The first quadrant decreases from 1 to 0, second quadrant again decreases from 0 to minus 1, third quadrant increases from minus 1 to 0, fourth quadrant increases from 0 to 1. In the first quadrant, the graph of cos function, what happens? Decreases. Arrow mark down means decreases from 1 to 0. In the second quadrant, what happens? In the second quadrant, it is again decreasing from 0 to minus 1. Decreases from 0 to minus 1. In the third quadrant, it is increasing from minus 1 to 0. Increases from minus 1 to 0. And in the fourth quadrant, it is increasing from 0 to 1. Decreasing, decreasing, increasing, increasing. Increases from 0 to 1. Nature of cos function in each quadrant. Decreasing, decreasing, increasing, increasing. Next, I'll go to the graph of y is equal to tan x. Graph of y is equal to tan x. Graph of y is equal to tan x. Mark the quadrantal angles. Unlike the sine function and cosine function, tan function, cot function, secant and cosec, they are not defined at all the points. Tan function is not defined at every odd multiple of pi by 2. Pi by 2, pi, 3 pi by 2, 2 pi. The quadrantal angles are marked here. On left side of origin, and mark the negative values. Minus pi by 2, minus pi, minus 3 pi by 2, minus 2 pi. And I'll mark the dotted vertical lines at pi by 2, 3 pi by 2 minus pi by 2, showing that the function is not defined. The function is not defined at those points. Dotted vertical lines are drawn. Tan 0 is 0, tan pi by 2 is infinity. In first quadrant, tan function increases from 0 to infinity. Second quadrant increases from minus infinity to 0. Third quadrant increases from 0 to pi. Third quadrant increases from 0 to infinity, 0 to infinity, goes up like this. And in fourth quadrant increases from minus infinity to 0, like this. This is fourth quadrant, minus pi by 2 0, it increases from minus infinity to 0. Here it is increases like this, passes through minus pi like this. And this is first quadrant, increases from minus 0 to infinity, increases from 0 to infinity here. In every quadrant, the function is increasing. In the first quadrant, tan function increases from 0 to infinity. Second quadrant increases from minus infinity to 0. Third quadrant increases from 0 to infinity. And fourth quadrant increases from minus infinity to 0. In first quadrant, tan function increases from 0 to infinity. 0 to infinity. In the second quadrant, it increases from minus infinity to 0. Arrow mark up means increases. Tan function is increasing in every quadrant. In third quadrant, it increases from 0 to infinity. Increases from 0 to infinity. And in the fourth quadrant, it increases from minus infinity to 0. In every quadrant, tan function is increasing. Next we go to graph of y is equal to cot x. Graph of y is equal to cot x. Mark the quadrilateral angles, pi by 2, pi, 3 pi by 2, 2 pi. Cot function is not defined for n pi. So where it is not defined, you can draw the dotted vertical lines. The dotted vertical lines can be drawn at such points. At pi, at 2 pi, at minus pi, at minus 2 pi, at such points. The function is not defined. Tan function in the first quadrant decreases from infinity to 0. Infinity to 0 decreases. Again it decreases like this. In each quadrant is decreasing, unlike the tan function. Cot function is decreasing in each quadrant. Comes down like this. Decreases like this. First quadrant decreases from infinity to 0. Second quadrant decreases from 0 to minus infinity. Third quadrant decreases from infinity to 0. Fourth quadrant decreases from 0 to minus infinity. The graph of y is equal to cot x decreases in the first quadrant from infinity to 0. From infinity to 0. Arrow mark down is decreasing. Arrow mark up is increasing. In the second quadrant decreases from 0 to minus infinity. Decreases from 0 to minus infinity. In the third quadrant, decreases from infinity to 0. Decreases from infinity to 0. And in the fourth quadrant, decreases from minus infinity to 0. Decreases from 0 to minus infinity, Decreases from 0 to minus infinity. Next, move on to the graph of y is equal to secant x. Tan function is increasing in each quadrant. Cot function is decreasing in each quadrant. Decreases from infinity to 0, first quadrant. Second quadrant decreases from 0 to minus infinity. Third quadrant decreases from infinity to 0. Fourth quadrant decreases from 0 to minus infinity. Move on to the next graph of y is equal to secant x. graph of y is equal to secant x. Mark the quadrantal angles. Pi by 2, pi, 3 pi by 2, 2 pi. Here it is minus pi by 2, minus pi, minus 3 pi by 2, minus 2 pi. Like tan function, even secant function is not defined for odd multiple of pi by 2. Pi by 2, 3 pi by 2, pi by 2, 3 pi by 2, minus pi by 2, minus 3 pi by 2. Secant 0 is 1, we know, and secant pi by 2 is going towards infinity, correct? So I'll mark the points 1 and minus 1 here, correct? Secant 0 is 1, secant pi by 2 is infinity, goes up this. The first quadrant it is positive, even in the fourth quadrant is positive. Here it is like this. In the second and third quadrant, secant function is negative. In the second and third quadrant, secant function is negative. Here it goes up like this. Secant of minus 2 pi is 1, so goes up like this. Graph of y is equal to secant x. And you can draw the graph here. In the first quadrant, secant function is increasing, correct? Increasing from 1 to infinity. Increases from 1 to infinity. Increases from 1 to infinity. In the second quadrant, secant function is increasing from minus infinity to minus 1. Increases from minus infinity to minus 1. And in the third quadrant, secant function is decreasing from minus 1 to minus infinity. Decreasing from minus 1 to minus infinity. Increases from minus infinity to minus 1, second quadrant. Third quadrant is decreasing from minus 1 to minus infinity. Fourth quadrant, it is decreasing from infinity to 1. Decreases from infinity to 1. Decreases from infinity to 1. Please make a note of this. Lastly, we draw the graph of y equal to cosec x. Graph of y equal to cosec x. Graph of y equal to cosec x. Mark the quadrantal angles. Pi by 2, pi, 3 pi by 2, 2 pi. This is minus pi by 2, minus pi, minus 3 pi by 2, minus 2 pi. Cosec function is not defined for every multiple of pi, like chord function. So draw the dotted vertical lines where it is not defined. At minus pi, at minus 2 pi, you can draw the dotted vertical lines. In the first and second quadrant, cosec function is positive, correct? Cosec 0 is infinity. I'll mark the points 1 and minus 1 on y-axis. So that cosec 0 is infinity, cosec pi by 2 is 1. It decreases from infinity to 1 like this. Goes up like this. And in the third and fourth quadrant, cosec function is negative. So it is below the x-axis like this. Here it is below the x-axis. Here it is above the x-axis. This is the graph of y equal to cosec x. In the first quadrant, it decreases from infinity to 1. Second quadrant increases from 1 to infinity. Third quadrant increases from minus infinity to minus 1. Fourth quadrant decreases from minus 1 to minus infinity. First quadrant, it is decreasing from infinity to 1. From infinity to 1. Cosec 0 is infinity, cosec pi by 2 is 1. In the second quadrant, it is increasing from 1 to infinity. Increases from 1 to infinity. In the third quadrant, it is increasing from minus infinity to minus 1. Increasing from minus infinity to minus 1. And finally, in the fourth quadrant, it is decreasing from minus 1 to minus infinity. Please make a note. Finally, I speak about the trigonometric substitution, which is very much useful in differentiation and integration. The trigonometric, the substitution, expression and substitution I can write. Expression and the substitution. If it is root of a square minus x square, we put x equal to a sin theta or a cos theta depending upon the given condition to simplify. A sin theta or a cos theta. If it is root of a square plus x square, if it is root of a square plus x square, we put x is equal to a tan theta or a cot theta. X equal to a tan theta or a cot theta. If it is root of x square minus a square, if it is root of x square minus a square, we put x is equal to a secant theta or a cosec theta. Because 1 minus sin square is cos square and 1 minus cos square is sin square, 1 plus tan square is secant square, 1 plus cot square is cosecant square. Because of that we have secant square minus 1 is tan square, cosecant square minus 1 is cot square. Because of that we have this substitution. If it is root of a plus x or if it is root of a minus x, in that case we put x is equal to a cos theta, or you can go for a cos 2 theta also. A cos theta or a cos 2 theta. If it is root of x by a minus x or if it is root of a minus x divided by x. Here we put x is equal to a sine square theta or x is equal to a cos square theta. If it is root of x by a plus x, or if it is root of a plus x divided by x, here we put x is equal to a tan square theta or x is equal to a cot square theta. If it is root of x by x minus a, or if it is root of x minus a divided by x, here we put x is equal to a secant square theta or a cosecant square theta. X equal to a secant square theta or x is equal to a cosecant square theta. Lastly, I write if it is root of a minus x into x minus b, or if it is root of a minus x divided by x minus b, we put x is equal to a cos square theta plus b sin square theta. In particular, I can give another table. In particular, expression with substitution, expression and substitution. If it is root of 1 minus x square, we put x is equal to sin theta or cos theta. If it is root of 1 plus x square, this is a particular case. In place of a, I have taken 1. Root of 1 plus x square, we put x is equal to tan theta or x is equal to cot theta. If it is root of x square minus 1, if it is root of x square minus 1, x is equal to secant theta or x is equal to cosecant theta. If it is root of 1 plus x or if it is root of 1 minus x, we put x is equal to cos theta or cos 2 theta, because we have 1 plus cos theta is equal to 2 cos square theta by 2, 1 minus cos theta equal to 2 sin square theta by 2. Root of, if it is root of x by 1 minus x, root of x by 1 minus x, root of x by 1 minus x, or if it is root of 1 minus x divided by x, we put x is equal to sin square theta or x is equal to cos square theta. Root of x by 1 plus x, or if it is root of 1 plus x divided by x, put x is equal to tan square theta or x is equal to cot square theta. These trigonometric substitutions are very much useful in chapters like differentiation and integration. Root of x by x minus 1, or if it is root of x minus 1 divided by x. Here we put x is equal to secant square theta or x is equal to cosecant square theta. This is the particular case of the previous one. Okay, I have given all in detail the formulas and concepts of trigonometric functions, entire chapter, including the properties of triangle as well as the trigonometric equations. The graphs also are drawn of all the trigonometric functions, correct? Cot x, tan x, cos x, sin x. We have the important half angle formulas in terms of the sides of the triangle and the perimeter area of the triangle, some of the results, and Napier's rule, projection rule, sine rule, cosine rule, all these things. General solutions of the trigonometric equation, general solutions of trigonometric equations and principal solution, how to find the principal solution, defactorization formula, maximum and minimum values of a cos x plus b sin x, and sum to n terms of sine series or cosine series when the angles are in AP, product of cosine series when angles are in GP, some of the important results connected to trigonometry. These are examples are given here, standard results connected to the multiple angle formulas, correct? Double angle formula, triple angle formula, half angle formula, all these things. Some of the important simplifications also we had here, correct? Important values also given here, correct? Important results connected to trigonometry, allied angles results connected to allied angles. All formulas are covered of trigonometry chapter in this session. Okay, concept of allied angles, coordinate angles, standard angles, maximum minimum values, domain in range of trigonometric functions, trigonometric identities, and also radian measure, all have been completely covered in this session. Many more videos will be uploaded in the coming days. Please subscribe to my channel and forward to your friends. And also the chapter wise formula revision will be done for all the chapters, including of first PU and second PU. And also I'll be doing KCT PYQ series from 1984 to 2025 for all our new viewers. I've done JEE main also from 2019 to 2025 of some topics. Many more videos will be uploaded in the coming days. Please subscribe to my channel and forward to your friends. Thank you.